Alright, in this lecture video we're going to talk about section 7.1, which are the trigonometric identities. And these trigonometric identities are really important for you to know off the top of your head. If you know these off the top of your head, it's going to make the problems that we go through a lot easier to follow, and you're also going to be able to solve your homework and your exam questions, and the final exam questions a lot easier. Some of these we already know, that the cosecant is 1 over the sine, the secant is 1 over cosine, and cotangent is 1 over tangent. So therefore also that the sine is 1 over the cosecant, the cosine is 1 over the secant, and then the tangent is just 1 over the cotangent. Those are the reciprocal identities. The quotient identities is simply just that the tangent is sine over cosine, and cotangent is therefore the cosine over the sine. These Pythagorean identities are cosine squared plus sine squared is equal to 1. 1 plus the tangent squared is equal to the secant squared, and the cotangent squared plus 1 is equal to the cosecant squared. We've already seen these odd and even function properties. Keep in mind that the sine, tangent, cosecant, and cotangent are all odd functions, and even functions are going to be the cosine and the secant. Now, I would suggest that until you know these off the top of your head, keep these handy, especially in this section. We're gonna try to apply these a lot. So first off, it says, simplify each of the following down to one term using the identities above. Alright, so let's see here. We have cotangent of x times the sine of x. Well, we know that the cotangent is equal to 1 over the tangent of x. And then here, we're going to still multiply it by the sine of x. Well, 1 over the tangent of x, we know that that's going to be equal to the cosine of x over the sine of x. And then if we still multiply that then by the sine of x, we see that sine of x is going to cancel that denominator. So therefore, this is just going to be equal to the cosine of x. Alright, so that's for number 1. For number 2, we have the cosine of theta times the cosecant of theta. Well, we know that the cosecant of theta, according to our definitions above, are simply just equal to 1 over the sine of theta. So therefore, we can rewrite this as the cosine of theta over the sine of theta, which we know is simply just equal to the cotangent of theta. So therefore, if we multiply the cosine of theta by the cosecant of theta, that's just equal to the cotangent of theta. All right, let's go on to number 3. Here we have that this is the cosine squared of x times the secant squared of x minus 1. Well, according to our definitions above, this is simply just the tangent squared of x. So therefore, what we can do then is we can write this as the cosecant squared of x. The tangent squared of x we can write as the sine squared over the cosine squared. So therefore, now what we can do is we can factor out a sine squared of x. No, I'm sorry. Factor out a sine squared of x. We can cancel cosine squared of x and the cosine squared of x down here in the denominator. So this turns into sine squared of x. That's what I meant to say. And we could leave it as this, but what we could also see above is that the sine squared of x is also simply just equal to 1 minus the cosine squared of x. But since it's asking us to just simplify this to one term, this sine squared of x right here, this is going to be our final answer. Alright, going on then to the next page in the notes. we have the secant squared of x times the tangent squared of x plus the secant squared of x. So here both of these terms have the secant squared of x in it. So we can factor out a secant squared of x term. Then here we're just left with the tangent squared of x plus 1, right? If we take the secant squared of x out of this, then that's just equal to 1. So therefore, that's where this plus 1 is coming from. But we know that tangent squared of x plus 1 is just equals to the secant squared of x. So therefore, if we have the secant squared times the secant squared, this then is just equal to the secant to the power of 4 of x. Then in number 5, sine squared of theta over cosine squared of theta plus sine of theta cosecant of theta. Well, we know that the sine squared of theta over cosine squared of theta is just equal to the tangent squared of theta. Now we still have plus sine of theta, and the cosecant of theta we know is equal to 1 over the sine of theta. So now the sine of theta is going to cancel with the sine of theta of the denominator, so we're going to have tangent squared of theta plus 1, and the tangent squared of theta plus 1 we know is just equal to the secant squared of theta. So for any of these, what I would suggest is, and especially with the problems that we're about to do, if that was a little bit quick for you, rewind the video, pause it before each problem, give them a shot by yourself, and see if you can do them. Obviously, you can continue to rewind and play the video and try these however many times it takes you until you get comfortable with them. But let's go over some of these general guidelines, or they're really just helpful ideas for whenever we solve these problems and also the examples that we're about to get into. So it says, let's talk about some guidelines that can be helpful when trying to verify identities, and that's what we're about to do in the next examples. For one, it says you must have your basic identities memorized, which are the identities that we just saw in the first box, the box at the beginning of this section, and the examples that we just went over. For 2, it says you should work with the more complicated looking side first. So we're going to try to pick the side that looks complicated, we're going to try to simplify it, and then we'll try to get the two sides of the equation to be equal to each other, and obviously equal to each other. But here's a really important point. It says, remember that you can't move terms from one side to the other side of the equation or multiply both sides by something. So we can't do what we're used to doing in simple algebra when we're dealing with something that isn't a trig function. We're not going to be able to do some of those things now that we're dealing with trig functions. For number 3, it says, typically you will want to add fractions together, simplify fractions so that they have monomials in the denominator, and or factor when possible. So whenever we're working on just one side of the equation, we can still manipulate stuff in these different ways. It says, look for number 4, it says, look for opportunities to use trigonometric identities to get functions that are the same or that are paired up like sine and cosine, or tangent and secant, or cotangent and cosecant, or that are paired up with the other side of the identity. So basically this is saying, see if you can use some of these trig identities that we had before, especially the Pythagorean identities that we had above in the box. Number 5 is one that I like to employ a lot, and definitely the one that I'm going to try to implement in one of these next couple of examples that we do. And that is, another strategy might be to convert everything to sine and cosines. A lot of times when stuff is written in sine and cosines, if there is a trig identity that you feel comfortable with, chances are it probably is either sine or cosine. So we can just simplify everything down to having nothing but sines and cosines in them. We can identify stuff that we can cancel out pretty easily. So this is definitely one that we're going to try to do. Number 6 says, you might want to multiply the numerators and the denominators of fractions by something in order to create the difference of two squares, like multiplying 1 plus sine of x by 1 minus sine of x, or to get 1 minus sine squared of x, which equals to cosine squared of x. So when it says multiplying stuff here, what it's very specific about is that we're only multiplying numerators and denominators by stuff on one side of the equation, right? Remember that if you multiply something by 1 minus sine of x over 1 minus sine of x, that's just like multiplying it by 1. And we can do that to one side of the equation. But keep in mind, like we said above, that we can't just move terms from one side to the other or multiply both sides by something. Then in number 7, if nothing comes to mind, just try something. It may lead somewhere, it might not lead somewhere, but hopefully it can help you identify something if you just start messing around with stuff a little bit. Alright, so these are just some general guidelines. Let's go on to the next couple of examples on the next page of the lecture notes. For these next couple of examples, it says verify that each of the following is true. So we're going to try to make the left-hand side of the equation verify that it's equal to the right-hand side of the equation. Again, we're not going to move stuff from one side to the other side. We're just going to try to manipulate one side. And if you remember, one of the previous guidelines on the previous page says, start with the more complicated looking side first. So generally speaking, that's going to help us out a lot. And it will in this example right here for number 6. So obviously the left-hand side is a more complicated looking side. So let's see what we can do with this thing here. On the outside of our parentheses, we have sine. Then we know that the cotangent is simply just 1 over the tangent of theta plus the tangent of theta. And this is then still going to be equal to secant of theta. I'm not doing anything to the right-hand side of the equation yet. Well, 1 over the tangent of theta, we know that this is simply just cosine of theta over the sine of theta. So therefore, a tangent of theta is the sine of theta over the cosine of theta. And here this is equal to the secant of theta. So here what we've done is we use some of these identities, and now we've also broken everything down to nothing but sines and cosines. So let's see what we can do with this. If we multiply this sine of theta inside, it's going to cancel out this first denominator. And then for our second term, our numerator is going to turn into sine squared of theta over cosine of theta. And I still have not done anything to the right-hand side of the equation. So what we can do now is here we have a cosine of theta, here we have a cosine of theta. One of the things that we can try to do is we can factor out a cosine of theta. Now why would that help us? Because now this is going to turn into 1 plus the sine squared of theta over cosine squared of theta. And what you can then recognize is that this right here is simply just 1 plus the tangent squared of theta. Well, the 1 plus the tangent squared of theta is equal to what? 1 plus the tangent squared of theta is equal to the secant squared of theta. Oh, you can't see that. Let me shift this over a little bit. Alright. Alright, so now how does that help us? Well, we can rewrite this then as the cosine of theta times 1 over the cosine squared of theta. And now, if we multiply the cosine theta in, we know that this is then just going to be 1 over cosine of theta. And now we've got to something that we know is true. So now we haven't done anything to the right-hand side of the equation. We did a whole lot of stuff to the left-hand side of the equation to get to the point where we can verify that the left-hand side is in fact equal to the right-hand side. Now, these are steps that I went through. There are a lot of different ways that you can verify that the left-hand side of the equation is equal to the right-hand side of the equation. Like I said, I first boiled everything down to the sine and cosines, and then I factored stuff out, and then I had some other identities here, and then I multiplied stuff back inside, right? You might like to take a different approach. There are different ways to solve this, but here's one of those ways. All right, let's go on to number 7. Sine squared of theta plus cotangent squared of theta plus cosine squared of theta is equal to the cosecant squared of theta. Well, one of the things that we know is that the sine squared of theta plus the cosine squared of theta is equal to what? Well, the sine squared of theta plus cosine squared of theta is just equal to 1. So all that I did right here is I just rewrote the left-hand side of the equation to put the sine squared of theta and cosine squared of theta next to each other so that we can recognize that these two things, based off of one of our Pythagorean identities, is equal to 1. Well, now we have 1 plus the cotangent squared of theta, which is also one of our identities in the box. So therefore, here now we verify that the left-hand side of the equation is in fact equal to the right-hand side of the equation. Like I said, you can pause the video at any time to give some of these a shot by yourself. So just because I keep going on, you can definitely pause it and rewind it, listen to it again, or give it a shot by yourself. Let's go on to number 8. The sine squared of theta over cosine of theta is equal to the secant of theta minus the cosine of theta. Alright, well now I happen to think that the right-hand side of the equation looks a little bit more complicated. So let me work with the right-hand side of the equation. So I won't touch the left-hand side. And I know that the secant of theta is 1 over the cosine of theta. And I still have it minus the cosine of theta. Now what I can do is I can factor out a cosine of theta. So now this is going to become 1 over the cosine squared of theta minus 1. And then this quantity times the cosine of theta, so that if I factored it back inside or I multiplied it back inside, I would get back to my original equation. Well, 1 over the cosine squared of theta is simply just the secant squared of theta. And I know that the secant squared of theta minus 1 is just equal to the tangent squared of theta. So I'm going to have the tangent squared of theta times the cosine of theta. And the tangent squared of theta I know is equal to sine squared of theta over cosine squared of theta. And obviously here I'm not touching the left-hand side of the equation, So the left-hand side of the equation is still sine squared of theta over cosine of theta. Which means now that if I multiply this first term by cosine of theta, one of these cosines in the denominator cancels, which leads me to, on the left-hand side of the equation, I have sine squared of theta over cosine squared of theta, and now I also have that on the right-hand side of the equation. So now I have verified that the left-hand side is equal to the right-hand side. Alright, that's number 8. Let's go on to number 9 on the next page of the notes. Again, you can try to pause the video. Make sure that you have the first page of the notes of this section handy, that box that I put up with the definitions. That way you can look at those definitions as we're going through these, or you can keep referring back to those as you're solving these yourself, and then playing a lecture video to see if you got it right. Alright, so let's do number 9. Secant squared of x minus 1 over the secant squared of x is equal to the sine squared of x. Well, the left-hand side now looks more complicated again. And what we can do is, we can still break the left-hand side apart into the secant squared of x over the secant squared of x minus 1 over the secant squared of x. So therefore, all I did right here is I broke up the numerator. These still have the same denominator. So this right here is now just equal to the sine squared of x. Well, the secant squared of x over the secant squared of x is just equal to 1. And 1 over the cosecant squared of x is equal to the cosine squared of x. And according to our Pythagorean identity, we have that the left-hand side is now equal to the right-hand side. Let's go on to number 10. Cosine of negative theta over the secant of theta plus the sine of negative theta over the cosecant of theta is equal to the negative sine squared of theta. Alright, well, we know that cosine is what? What kind of function is the cosine? And it's an even function. So if cosine is an even function, then we know that we can just rewrite this as the cosine of theta over the secant of theta. Now, what about the sine of theta? Is sine even or odd? And the sine is odd. So since the sine is odd, what this then is going to become is we can pull this negative out front, so it becomes minus the sine of positive theta, and we're still multiplying this to the cosecant of theta. And again, we're not touching the right-hand side. So here we have plus a minus, so we can simplify this to just a minus. Now what we can do is we can write this as the sine of theta, and the cosecant we know is 1 over the sine of theta. Again, we're not touching the right-hand side at all. And here we have the cosine of theta over the secant of theta. So we know that the secant of theta is just 1 over cosine. So then we have 1 over cosine in the denominator. So then this is going to become the cosine squared of theta. Well, Now we can carry this down as the cosine squared of theta. Here we're going to have this cancel out the denominator, so we're just going to have minus 1 is equal to the negative sine squared of theta, which we know now is equal to our Pythagorean identity. Alright, let's go on to number 11. Sine squared of t is equal to the tangent of t, cotangent of t, minus cosine squared of t. Alright, well clearly the right-hand side now looks a little bit more complicated. And what we can do is we can rewrite the cotangent of t as 1 over the tangent of t. Won't touch this cosine squared of t here for a second, because we know that tangent of t times 1 over the tangent of t is simply just equal to 1. So therefore here we have sine squared of t is equal to 1 minus the cosine squared of t. And that, again, is a Pythagorean identity. So we verified that the left-hand side is equal to the right-hand side. Let's go on to number 12. Secant times the cosecant of theta over the cotangent of theta is equal to the secant squared of theta. So now the left-hand side looks more complicated. So let's see what we can do here. I won't touch the right-hand side. I'll bring down the right-hand side. We know that the secant is equal to the 1 over the cosine of theta. The cosecant is equal to 1 over the sine of theta. And the cotangent is equal to 1 over the tangent of theta. So now, I can still, so what I'm doing is I'm taking everything down to sines and cosines. So here then, we're going to have the secant squared of theta still on the right-hand side. We have 1 over cosine of theta times 1 over sine of theta. And the tangent of theta is simply just going to be sine over cosine. So instead of writing it as 1 over sine over cosine, I'm just going to write this as the cosine of theta over the sine of theta. So now what we can do is we can rewrite this as 1 over the cosine of theta times the sine of theta. I'm going to multiply this by its reciprocal, so this is going to become sine of theta over cosine of theta, which we now know is going to be equal to 1 over the cosine squared of theta, which is exactly equal to secant squared of theta. So now, again, we verified that the left-hand side is equal to the right-hand side. Alright, if we go on to the next page of notes, and all that we're doing in all of these is just using the identities from the first page of the lecture notes for this section. So again, if these are seeming a little bit quick to you, you can always pause the video, look at those identities on the first page, try them out by yourself, see if you can answer the question, and then play the video or rewind it to make sure that you can follow along. Alright, so for number 13, we have 1 over 1 minus the sine of theta plus 1 over 1 plus the sine of theta is equal to 2 times the secant squared of theta. Well, here I think that the left-hand side looks more complicated. So let's work with the left-hand side. So I'm just going to copy down this right-hand side and not do anything to it. Well, 1 minus the sine of theta and 1 plus the sine of theta, we don't really know anything that's any kind of identity that uses that. But what we do know is that if we have 1 over, here let me give myself a little bit of extra room. If we have 1 over 1 minus sine of theta, if we multiply this by 1 plus the sine of theta over 1 plus the sine of theta, we've seen this concept before. This is going to help us simplify stuff. We can do that the same thing with this. So all I worked with so far here was this first term. And I just multiplied it by 1 plus the sine of theta over 1 plus the sine of theta, which is just the same thing as multiplying it by 1, since our numerator is the same thing as our denominator. I'm now going to use this second term, which is 1 over 1 plus the sine of theta. And I'm going to do the same thing, but now I'm going to multiply it by 1 minus the sine of theta over 1 minus the sine of theta. So again, all I'm doing is I'm multiplying both of these two terms by something that is equivalent to the number 1. Alright, so now how does this help us? Well, what we can do is, let's take a look at this numerator over here first. 1 times 1 plus the sine of theta is just 1 plus the sine of theta. So that's what we have in our numerator. But now what do we have in our denominator? Well, if you multiply this out, we're going to get 1 plus the sine of theta minus the sine of theta minus the sine of sine squared of theta. And here, in the second term, if you look at the numerator, it's just going to be 1 times 1 minus the sine of theta. So again, here we're going to get 1 minus the sine of theta. And if you multiply out the denominator, we're going to get 1 minus the sine of theta plus the sine of theta minus the sine squared of theta. And again, we're not doing anything to the right-hand side of the equation. Well, if we look at this now, if we look at our denominators, so here I'm going to carry the numerator. I'm not doing anything with the numerator. This denominator now is just 1 minus the sine squared of theta. And this is 1 minus the sine squared of theta. Well, here we have a common denominator. So I can write all of this as 1 plus the sine of theta plus 1 minus the sine of theta. So I'm combining the numerators over 1 minus the sine squared of theta. And if you see now here, this numerator, these signs are going to cancel. So I'm going to get 2 over 1 minus the sine squared of theta. And we know that the sine squared of theta, 1 minus the sine squared of theta, is simply just cosine squared of theta. So we have 2 over the cosine squared of theta, and 1 over the cosine squared of theta is just equal to secant squared of theta. So therefore, all of this is equal to 2 times the secant squared of theta, which was what we had on the right-hand side of our equation. So therefore, we've now verified that the left-hand side is in fact equal to the right-hand side. Alright, let's go on to number 14. Number 14 says, sine of x minus cosine squared of x times the sine of x is equal to sine cubed of x. Well, one of the things that we can see here is that both of these terms have a sine of x in it. So let me factor out that sine of x. I get 1 minus the cosine squared of x. I'm not going to touch the right-hand side of the equation, but I know that 1 minus the cosine squared of x is simply just equal to the sine squared of x. And I think everybody will agree now that the left-hand side is equal to the right-hand side. And I don't know how this became a theta, because here we're just using x's. Alright, that's number 14. Let's go on to number 15. 2 times the cosecant of theta over the secant of theta plus the cosine of theta over the sine of theta is equal to 3 times the cotangent of theta. So let's see here. We can rewrite the cosecant of theta as 1 over the sine of theta. So then up here in the numerator, we have 2 times this, right? 2 times 1 over the sine of theta. In our denominator for this first term, we have the secant of theta, and the secant of theta is just the same thing as 1 over the cosine of theta. Now we have plus the cosine of theta over the sine of theta. We know that that is equal to the cotangent of theta. And again, I'm not touching the other side. So what we can do now is we can multiply this by, multiply the numerator of the big fraction by the reciprocal of the denominator of that fraction. So then what we're going to get is 2 times the cosine of theta over the sine of theta plus the cotangent of theta, right? I'm just carrying these things down because I'm not changing anything about them. And the cosine of theta over the sine of theta, that's just equal to the cotangent of theta. So therefore, if we have 2 times the cotangent of theta plus another cotangent of theta, here clearly we're going to have 3 cotangents of theta. So clearly the left-hand side is equal to the right-hand side. Alright, so in this section, we practice some of those trig identities, and we also practice verifying that 2 sides of the equalities are in fact equal to each other. I highly recommend for this section that you go back and you practice these. This section tends to be pretty hard for most people. So go back and practice these until you feel comfortable with them. Once you feel comfortable with these, the next sections are going to become easier. But if you're struggling with these, then you're also going to be struggling with future sections. So please make sure that you take the time and you practice these problems. And you also complete the practice problems for this section.